Sometimes in the ocean of dark between the stars, silence is louder than thunder. Imagine a clockwork heart beating 100 times each second, its rhythm echoing through the black, yet no mortal ear can hear it. Out there, a titan of gravity dances with a naked ember, a star whose own skin has been torn away, left bare by cosmic violence. Their orbit is so tight, their touch so intimate, that they seem to whisper secrets in the language of X-rays and radio waves, secrets only the most patient eyes and the deepest ears can catch. What does it mean when the death of one star becomes the heartbeat of another? In this cosmic duet, what truth waits to be found? But what lies behind this cosmic veil? Across the architecture of the universe, where clouds of hydrogen birth new suns and black holes swallow light itself, there exist rare harmonies, unlikely couples whose union shapes the fate of galaxies. Picture a millisecond pulsar, a sphere of degenerate matter, no wider than a city, spinning nearly 100 times every second. It is the corpse of a massive star, collapsed and compressed, magnetic fields wound tight as a watch spring. Now bind it to a partner, a stripped helium star, the remnant heart of a companion whose atmosphere has been peeled away in a slow, devouring spiral. The two are locked in an orbit only 3.5 hours long, a waltz faster than any planet's day. Each revolution brings tidal forces, friction, and a tension that warps both bodies. We observe them not by sight, but by the trembling of radio pulses, a strobe of ancient violence captured by the 500-meter aperture spherical telescope. Fast, the ear pressed closest to the night. Their very existence is a puzzle piece in the grand story of stellar evolution, direct evidence of the so-called common envelope phase, a fleeting moment when two stars share a single swollen atmosphere before one is stripped bare and the other left spinning. Such systems are not just beautiful, they are harbingers. Their tight embrace, their X-ray whispers, and their decaying orbits point toward a future where gravity wins and the two merge, unleashing gravitational waves, ripples in space-time itself. They are laboratories for the extremes, where matter, energy, and time are bent. But how many such encounters are hidden, buried in the infinite clockwork of the cosmos? What truths might be hidden within this infinite architecture? If you've felt the hush of wonder in this story, if, for a moment, you've heard the pulse of that distant clock, let your thoughts join ours. Whisper your questions, your awe, your reflections into the night below. Every comment is a ripple, a faint echo that shapes the next story we tell. If this journey touched some hidden chord within you, let your voice linger here, a fragment of starlight in the dark. Let's return to where it all began. Before the first pulse, before the first orbit, there was only chaos and silence. The universe itself was a newborn, a storm of particles, light, and gravity, unshaped and unclaimed. Stars were not yet born, only the prospect of their fire flickered within the formless soup. In this primordial dusk, gravity began its slow, tireless work. Clouds of hydrogen, cold as the void, drifted and gathered, collapsing into the furnace of nuclear fusion. Suns lit themselves, and in their bellies, elements heavier than hydrogen and helium were forged. Some of these stars were giants, living fast and dying young. Their deaths were cataclysms, supernovae that scattered gold, iron, and carbon into the void. In those moments, the boundaries between destruction and creation blurred. A star's collapse did not end its story. Sometimes it became something stranger, a neutron star so dense that a teaspoon would outweigh a mountain, a remnant so small yet so powerful that it could outshine an entire galaxy in a single burst. But what of their companions? In crowded nurseries of stars, binaries were born, pairs locked by gravity, destined to shape each other's fate. Sometimes as one swelled into a red giant, its outer layers spilled over, smothering its partner in a common envelope. Inside this suffocating shroud, friction stole their energy, shrinking their orbit, drawing them ever closer. The envelope was shed, cast into space, and what remained was a ghost and a survivor. A stripped core and a neutron star bound in a desperate, doomed embrace. From chaos, then, came order, patterns etched by gravity and time, written in the ashes of stellar death. And yet, for all our telescopes and theories, so much remains veiled. What remains buried in that ancient silence? Science, too, is a kind of memory, a diary written in particles, waves, and equations. When we point our instruments skyward, we read the echoes of ancient violence. Light travels for eons before finding us, bearing the fingerprint of the stars' hidden lives. Radio telescopes, like FAST, do not merely listen. They sift through cosmic diaries, decoding pulses that repeat with the precision of an atomic clock. That is how we found PSR J1928 plus 1915, its millisecond heartbeat threading through the static, revealing a story written long before our species had words. Each pulse, each X-ray flare, is a page from a time capsule. Direct evidence that the common envelope phase was real, not just theory. The stripped helium star's spectrum is a confession of its lost youth, its orbit, a record of the violence that bound it to the pulsar. In these emissions, we find traces of nucleosynthesis, the alchemy of elements born in the hearts of dying stars. The radio waves tell us about rotation, magnetic fields, and the energy lost to space. The X-rays unveil accretion, the slow siphoning of matter from one star to another, and the heat that friction brings. We are reading a history not just of matter, but of transformation, of death giving rise to new forms, of energy transmuted and carried across time. Every data set is a fossil, every spectrum a memory. Yet beneath these records, something is still alive. Imagine descending, not into a cavern of stone, but into a landscape built of force and probability. The surface of a neutron star is no more real than the edge of a shadow. Its crust is a millimeter-thin veneer atop a core so dense that atoms themselves collapse. There is no air, no light, no place for the familiar shapes of life. Temperatures soar, gravity crushes, and magnetic fields twist space into impossible geometries. The companion, once a star in her own right, is now a stripped skeleton, a ball of helium shorn of her hydrogen dress, spinning around her partner at a distance so close that tides stretch and squeeze her body. Their orbit is a racetrack carved through emptiness, each lap completed in just a few hours. We cannot see this with our eyes. Even the best telescopes capture only hints, a pulse here, a flicker there, a spectral fingerprint. It is a landscape of hidden violence, of energies beyond comprehension, of matter rearranged by forces that defy imagination. The magnetosphere of the pulsar reaches out, creating auroras of death on the surface of its companion. In this arena, matter and energy dance to the tune of relativity and quantum mechanics. Yet for all this, a kind of order emerges. The orbit is predictable, the pulses are steady, the violence becomes a rhythm, the chaos a pattern. But what kind of life waits inside this silence? Life, it turns out, is not only a property of water and carbon. It is the persistence of order against entropy, the refusal to yield to oblivion. Even here, in the most hostile environment imaginable, there is resilience. The pulsar, born from collapse, endures by spinning, its rotation a buffer against the decay of time. The stripped helium star, though ravaged, persists, orbiting with unwavering loyalty. Their dance is a testament to survival against all odds. On Earth, life clings to volcanic vents, frozen deserts, and acid pools, places once thought barren. We adapt, change, and persist, as do these cosmic survivors. The neutron star's very existence is defiance. It should have been destroyed, yet it remains, a relic of violence made into a beacon. There is hope in this. If matter can endure such extremes, if order can emerge from such chaos, then what of us? Our own challenges, our own losses, may seem overwhelming, but the universe whispers, persistence is possible. The stars themselves have been broken and remade, and still they shine. If life finds a way there, what are we capable of surviving? This is where the story trembles, becomes urgent. The universe does not wait. Every pulse, every orbit, every fleeting second is a countdown. If you feel that urgency, if the persistence of these stars stirs something restless in you, share it. Comment what this awakening means to you. Let others know they are not alone in their wonder or in their fear. Time is running and every voice matters, and yet something is unraveling fast. Collapse is not just a metaphor. It is a process, relentless and real, both out there and here at home. In the binary system, the orbit is shrinking. As gravitational waves carry energy away, the two stars spiral ever closer, their fate sealed by physics. Sooner or later, they will merge, unleashing a storm of energy that will ripple through space-time, a signal for future astronomers, a punctuation mark in the cosmic diary. On Earth, too, we feel the press of collapse. Ice caps melt, ecosystems falter, and the atmosphere thickens with the breath of our industry. Our own systems spin toward crisis, their orbits decaying from the slow erosion of time and carelessness. The parallels are impossible to ignore. What happens in the heart of a star is not so different from what happens in the heart of a civilization. Irreversible changes begin quietly. A wobble here, a warming there, a species lost, a data point missed. Then, suddenly, the tipping point arrives. In the binary, the common envelope phase is both destruction and rebirth. One star is stripped, the other is spun up, and together they become something new, sometimes stable, sometimes doomed. The collapse is beautiful in its inevitability, but it is also a warning. The laws that govern stars also govern us. Neglect invites disaster, but awareness brings the chance of transformation. As the pulsar and its companions circle their doom, we are asked to reckon with our own trajectory. What will we do as the collapse accelerates? Will we become beacons or warnings? And in that unraveling, new powers begin to stir. For not all collapse is loss. Sometimes in the shedding of skins, in the shrinking of orbits, new possibilities arise. The discovery of PSR J1928 plus 1915 is more than a curiosity. It is a window into the future of science, economics, and power. Astrophysicists dream of mining the data these systems provide, insights into gravity, matter, and energy that could revolutionize our understanding of the universe. But others dream of mining the stars themselves, harvesting exotic elements from neutron stars, or using their gravitational fields for propulsion or weaponry. Inequality, too, finds its echoes here. Who owns the knowledge gleaned from the stars? Who controls the resources, the patents, the power? The history of rare earths and precious metals on Earth is a story of exploitation, of wealth pooled in the hands of a few, of landscapes scarred for fleeting gain. Will space be any different? The pursuit of gravitational wave sources could become a scramble, a new gold rush, with nations and corporations vying for control. Ethical dilemmas multiply. Is it right to disrupt these ancient systems for our own ends? Can we justify the risk, the consequences? The common envelope phase is a laboratory for more than physics. It is a crucible for our values, our ambitions, our fears. Knowledge is power, but it is also responsibility. The data from FAST is shared, but not equally. Access is governed by politics, funding, and privilege. As we unravel the secrets of PSR J1928 plus 1915, we must ask ourselves, who benefits and who is left behind? The future of stellar evolution is not just a question of science, but of justice. And so we ask, who shapes the future and who is forgotten in its shadow? The path ahead branches, as all futures do. In one vision, the lessons of PSR J1928 plus 1915 are ignored. Space becomes a new frontier for greed and conquest. The rare resources of the cosmos are hoarded by the powerful, and knowledge becomes a weapon. The collapse of systems, stellar, social, environmental, accelerates unchecked. The merging of stars is mirrored by the merging of crises, and the ripples of destruction spread, heedless of borders. But another future glimmers. We listen to the heartbeat of the pulsar not for profit but for wisdom. The data is open, the science shared, the discoveries used to heal rather than harm. The common envelope phase becomes a metaphor for empathy. We acknowledge the violence of the past, but choose to shed it, to orbit closer in understanding and cooperation. The merging of stars is not an end, but a beginning, a source of new energy, new hope. You, standing at the pivot, are not a bystander. The choices we make, the voices we raise, the questions we ask, these shape the branching of the future. Will we repeat the mistakes of the past or chart a new course? The universe offers no guarantees, only possibilities. In the end, it's not just a story of stars, it's a story of us. Let this story echo within you. If the pulse of the millisecond pulsar, the persistence of the stripped helium star, the urgency of their spiral has left a mark, let your comment be the echo that shapes what comes next. Share your wonder, your worry, your hope. In this vast night, every voice is needed, every reflection a lantern for those who follow. Now let us fall into silence. In the hush that follows, the question lingers. If the death of one star can spark the life of another, if the unraveling of one order can burst something wholly new, what might we become together if we listen and remember and reach across the darkness? The universe waits, silent and patient, and so do we.